Okay, number 5 looks like this. I'm going to say this is the time for bacteria's growth, and it looks like this relationship. So time equals ln of the bacteria growth minus ln of 150 over 0.32. Find the time for the bacteria to reach 10,000 in number. So we're going to plug that 10,000 in for bacteria and solve for time. So it's sort of a plug and chug. ln of 10,000 minus ln of 150 divided by 0.32. So you'll just have to be able to use a formula that has logs in it. 13.12 hours when you tap it out. Alright, let's look at solving equations with logs in them. So I'm going to ask you to solve this. So it has to have some unknown in it. There it is. Alright, you'll recall to write an expression with log in it, to take that log out and write an equivalent expression without, it's always the base, this raised to this equals this. So 4 raised to the 2 equals 3x plus 1, or 16 equals 3x plus 1, or 15 equals 3x, or x equals 5. Alright. We always have to check and see if that creates an argument that is 0 or negative. So we don't have to check at the whole equation, but just the argument. That's this part. So 3 times 5 is 15 plus 1 is 16. That is a positive number, and we have checked that our answer is legit. All right. Let's leave logs. That's a little review on logarithms, and let's look at some trig. Let's change this degrees to radians. So usually I write the word degrees for clarity. I'm going to multiply it times a form of 1. Do you remember how many radians are in how many equivalent degrees? So one of the easier spots is to remember is like on a unit circle right here. How many degrees is that and how many radians is that? Well, it turns out it's 180 degrees, and it's the same as pi radians. So that is equivalent to that. So this is a big fat 1, and it allows degrees to cross out, and what we have remaining is 40 times pi in the numerator and 180 in the denominator. So we always want to reduce, and that will reduce to 2 pi over 9, and that is radians. All right, let's go the other way. So in problem number 8, let's take 3 pi over 8 radians and change it to degrees. So we're going to use the same unit multiplier upside down. So we're going to have, so this is in radians, when even though it doesn't say, I'll write it in for clarity. So we're going to multiply by 180 degrees over pi radians. So radians crosses radians, pi crosses pi. 8 will go into 180, will it not? Let's see, it goes twice, 16, 20, no, not evenly. Alright, well, anyhow, when I multiplied this out, 3 times 180 divided by 8, I got 135 over 2, or 67.5 degrees. Alright, and you can verify that. Fraction work. Alright. We'll do like 12 problems tonight. The next one, number 9, is to evaluate without a calculator the tangent of negative pi over 3. So without a calculator, we pull out our unit circle. And pi over 3, you'll recall, if I divide each half of the circle into sixths, or the whole one into twelfths, pi over 3 is right here. And if I want to go negative pi over 3, I'll start here and go just as far in the other direction. So that takes me there. And I need to know the coordinates there. So this is over the short and down the long. So over 1/2 and down negative square root of 3 over 2. Tangent is the second divided by the first. So we flip and multiply, and we get negative square root of 3, and I can't even read what I wrote. Let me see if I can zoom in, not out. Alright, so I had negative square root of 3 over 2, the 2's canceled, and I have negative square root of 3 over 1, which is just negative square root of 3. Alright, so that is the tangent of pi over 3, negative pi over 3. Alright, let's look at number 10. Number 10, let's like have an A and B to number 9. So that's A. Bringing that back to mind, let's see what B is. Try cotangent of negative pi over 3. Alright, since we already have pi over 3 pictured, cotangent of that spot is going to be, instead of the second divided by the first, cotangent is going to be the flip of that. And so we already know what tangent is, so we're just going to flip it upside down to get cotangent. So that would be negative 1 over the square root of 3. But we always rationalize when we have square roots in the bottom, and we get negative square root of 3 over 3. And that is the cotangent. So now number 10. Get another paper. Say we have a 6-foot ladder at a 43-degree angle. Let's go the other way so I can get the whole picture in here. Alright, so here's a 6-foot ladder, and it makes a 43-degree angle with the ground, and how far up the wall does it reach? So we're looking for this height. So there's a trig function that relates these three parts. So from the perspective of this angle, this is opposite and this is hypotenuse. So we're talking about the sine function. So we can say the sine of 43 equals opposite over hypotenuse. And just solve for h. So multiplying both sides by 6, we get 6 sine of 43, which is a little over 4.09 feet is the height. Alright, let's remember a little more about our trig. If that was number 10, just 2 more. Let's evaluate without a calculator cosine inverse. Let's recall what inverse trig looks like. So that is saying what angle has a cosine of negative 1/2. And cosine inverse, we're only allowed to look at quadrant 1 and quadrant 2 for the cosine. So when I have my unit circle, I can only look in this quadrant or this quadrant, and so it's negative, so all of these are going to be positive. So I'm going to look either here, or perhaps the one in between. So let's see which one it might be. So this is 1/6 pi, 2/6 pi, that's 1/3, pi over 2. is 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi. So this is 2 pi over 3. So let's try there. -1/2 up square root of 3 over 2. So back the short, up the long is the cosine of that -1/2. It's the first coordinate is the cosine. It is -1/2. So therefore, the answer is this angle, which I identified as 2 pi over 3. That's what I tried to write in there. Not very legible. All right, number 12. Evaluate without a calculator the cotangent of the arc sine of 1/2. All right, so arc sine is another word for saying sine to the -1 or sine inverse. I could have called this arc cosine, same thing. So in arc sine, we're looking in the first and the fourth quadrants only. So it's positive, so I'm expecting it to be in the first. So this one. And I am going to go over, let's look here. That one we go over the square root of 3 over 2 and up 1/2. Sine is the second. So there we found it. So that value is pi over 6. So inside parentheses, I have pi over 6. The problem isn't finished because now it asks me for the cotangent of pi over 6. Well, the tangent is the second divided by the first. So the cotangent is the flip of that. It's the first divided by the second. The 2's cancel, and I get square root of 3. That is the answer to this problem. All right. Hope that is starting to bring a lot of things back to mind, and that will be helpful as we soon will face final week. All right. So when you come in on Monday, we will put aside our other work and we will work on review, review, review. The first thing you'll do is 12 problems just like these. Different numbers, but exactly the same concepts. When you finish those, we'll continue on in our review. All right, that's all for now. Carry on.